Welcome to the demo of Touchstone. First, we have the login screen. We sign in. We choose the demo environment, and we get to the landing page. In the landing page, we can see the main concepts of Touchstone that are the 13 environments, 186 text suites, no executions in progress, and 127 reports available. This is a demo environment, so these graphs don't have meaningful data. Now we're going to create a new environment. We go to the environments, select add new, we enter the name, the description, we select Open Kubernetes, we select a local provider, the version that we want, and we upload the usual config file that we use to authenticate to the cluster when we have the client. Okay. This will fill up all the URL, all the credentials to authenticate, and we just have to select the role of the user and click Save. Now we have the new environment, and when we can edit the settings. Okay, first we can select the settings for the network, where we select which network annotation definitions we will be using for SRIOV, the ones that we will be using for SRIOV kernel, and the ones that we will be using for normal VNIC. And then select at least the registry type, either public, hosted private, or hosted public, so that for the occasions when you have a registry that, and Touchstone is not connected to the internet. Now we're going to see some of the test suites that we can use to test the environment. We select the Kubernetes test suites for the industry benchmark. Okay. We can see here that we have performance test suites for throughput using SRIOV both on 10 gigs or 25 gig NICs, testing of the computer capacity, CPU and memory, the storage performance, and also besides DPDK, we can have kernel IP stack latency and kernel IP stack throughput. Then we have a test suite for the high availability of the infrastructure, and then the full Kubernetes functional and conformance test area that tests the Kubernetes against the standard end-to-end test that is used for the conformance of a specific Kubernetes version. Then we have two test suites checking the security conformance of Kubernetes according to the CIS benchmark, and some checking the vulnerability, some common vulnerabilities in the Kubernetes environment. Finally, we have a robustness test case that runs a burst of load on the control plane to see that is not only good at performance, but also in the robust, able to clear. Now, let's see what kind of test cases we can have in one of these test suites. For example, this is a test suite designed for a sample of test cases for a core benchmark. It has tests for storage performance, packet loss in the network side, memory latency for the CPU, memory bandwidth, and system performance that tests how much capacity the CPU has available for programs. A little bit more tests for storage, then some throughput tests on the kernel side, and some here in this with the tool Touchstone with the tool packaging, and then some latency tests and jitter test. Finally, we have a couple of SRIOV throughput test cases that will show you performance with the most high performance stack combination. Now we're going to show how we benchmark an environment. We go to the environment that we have here for testing, and we go to the benchmark option. Here it's downloading some information about the environment, and then we can validate the performance using the test suite that we just saw. We can put an execution title like pre-sales demo. We can put any kind of label that we will use it for finding more easily the execution. And then we can select the nodes that we're going to use to test. For example, we could use these each node separately, or we could use a group of nodes. We can also select if there are some tolerations that shouldn't be a problem for deploying the tests. And then we can select also different selectors and tolerations for the client and the server in the client-server test cases for networking. Two final options: we can enable the monitoring during test, and we can schedule this testing for later. So maybe we can do it every day at a time that is more convenient, or we can do it just once, but a little bit later. Now we will launch it right now. We can see it's now being executing. After some initialization time, it will show up here and see how it's running. Okay, we can see the results, some passed, some failed the SLA, and then we can go to the report and see what did we have. We can see the results. For example, the throughput SRIOV test case with DraftGen was not very good, with only 72,000 packets per second, but the one using PackageGen is performing much better with 768,000 packets per second. You can see that the initial runs are not good enough because they lost some packets, but then afterwards they don't lose the packets. After this one, we can also see some system performance test cases where we can see that the Unixbench score is not enough to get to the 4,000 mark. This will show that only 3/4 of what is usual will be available for the application to run their loads. Okay, we can also have a measurement of the latency between two pods. Here only 73 microseconds, but it's still above the expected value for the KPI, that is 70. And for example, also a jitter test where we can see that this is very low, only 4 microseconds of jitter with an SLA of 10 microseconds. Now the report can be also exported as Excel file, as an HTML file for offline browsing, or as a JSON for importing and exporting. We can also see that we have a feature to compare reports where we can see that after 2 tests, the second test improved. After fine-tuning the environment, we improved the jitter, improved the network latency. Some of the measurements of memory bandwidth were also improved, but not all. And the memory latency is markedly improved. This also includes some improvement in regular latency, that is 12-14% below. and the other ones are still in the same range of performance, and there's not much changes. Then we can see what is the monitoring data that we gather while we are testing. For example, these graphs here show the Blockio device usage and the operations in the disk and the bandwidth in the disk usage. Here, a very interesting graph of the DPDK traffic, where we can see that the first test is going okay with no drops and no errors, and the second one has to decrease the performance until we get to also 0 drops and 0 errors. Okay, then we can see that the regular traffic is very low. All traffic is going through DPDK. We can see the usage of memory increasing in both these cases, and also the CPU. The CPU is throttling in the second test case, even if it has the double amount of CPU, as we can see here. That's maybe explaining the bad performance. Okay, and then after the individual container stats, we can have system stats like system load, the synchronization status, the temperature and the power consumed by the whole system, the usage of the file system, and the disk time spent during in-prod operations per second, bandwidth per second. We can have the TCP and UDP traffic for the whole system, the full traffic statistics for the whole system in bits per second and in packets per second, the memory usage with memory page faults and all several types of memory usage, and finally the CPU usage of the whole system. You can see that in each iteration there is a lot of usage and then diminishes between them. Finally, we can see that Touchstone has an integrated help page, help system that shows all the Touchstone concepts, the portal access, all the test cases and contexts and scenarios for all the tests that are done. And there is also an API support page that can allow any user to try out the API. For example, doing a login operation and then launching the execution of the benchmark of an environment.